Hello dear students, today we are having a question written on the screen and the question says that find the angle of intersection of ellipse, and the equation of ellipse is the standard one and the circle x square plus y square is equal to AB. Okay, so basically what do you mean by angle of intersection? Angle of intersection actually means that the angle between the tangents. Okay, so as you can see in this diagram, there is this circle and there is the ellipse. So at the point P, two tangents has been drawn, one to the circle and one to the ellipse, and the angle phi that you can see in this diagram is the angle that we need to find. Okay, so I hope that it is clear that what is meant by angle of intersection. Now one thing you can see that A and B, regarding A and B, what inference we can draw? We can say that the semi-major and semi-minor axis of the ellipse are of length A and B. Okay, A is what? A is semi-major, and B is what? Semi-minor. Okay, B is the length of semi-minor. So, and the radius of the circle is root under AB. Okay, the radius of the circle is root under AB, and that is less than A, and this radius is greater than B. Thus, what we can infer? Thus, we can infer that the circle will intersect the ellipse in 4 points symmetrically. Okay, the circle will intersect the ellipse in 4 points symmetrically. Okay, so now coming to solving this question, how we are going to solve this? So let us say the point of intersection is P and it lies in the first quadrant, and let us assume, let us assume point P to be A cos theta and B sin theta. Okay, now P also lies on the circle. P also lies on circle. That means the coordinates of P will satisfy both the equation of ellipse as well as the equation of circle. So we can write A square cos square theta plus B square sin square theta is equal to AB. Okay, by putting this equation in the equation of circle. Okay, now from here what I can write? From here I can say that A square minus B square cos square theta is equal to B into A minus B. Okay, how I got this? By writing 1 minus cos square theta in place of sin square theta, and from here what I can write? From here what I can write is cos square theta is equal to B upon A plus B, and similarly we can find sin square theta is equal to A upon A plus B. Okay, so why we are finding these two ratios, it will be clear when we move forward. Now we got the value of cos square theta and sin square theta. Now we need to find the tangent of the ellipse at point P. Okay, so at point P, the tangent, what will be the slope of the tangent to the ellipse? Okay, so the tangent to ellipse has slope. What do we write the tangent to the ellipse? X upon A cos theta plus y upon B sin theta is equal to 1. Okay, so from here if I want to find the slope, what will be the slope? The slope is writing in the form of y is equal to mx plus c. So I can write it like this: y sin theta upon b is equal to 1 minus x upon a cos theta, and from here I can write y is equal to b upon sin theta and minus b upon a x cot theta. Okay, so from here I can say that the slope will be I'm just using other ink to highlight it. So slope will be nothing but minus b upon a cot theta. Okay, now what I got the value of cos square theta and sin square theta. I got that cos theta cos square theta is equal to b upon a plus b, and sin square theta is equal to a upon a plus b. So if I divide both, I can get the value of cot square theta, and that will come as b upon a. So I can write in place of cot theta root under b upon a, taking only only positive values, say, because I took it in the first quadrant, the angle. So this will be b upon a to the power 1 upon 2, right? Yeah. So this will be the slope will be minus b upon a to the power 3 upon 2. Okay. Okay, so I got the slope of the tangent to ellipse. Now coming to the next part, I need to find the slope of tangent to circle. Slope of tangent to circle. Why I am doing this? Because once I find the slope of tangent to ellipse and tangent to circle, then I can find the angle between these two tangents by coordinate geometry. So I want to find the slope of the tangent to the circle. Slope of tangent to circle. So I can write from here MC is equal to minus a upon b cot theta. Okay, you can write the equation of the tangent to the circle. It is quite easy, because if the equations of circle is x square plus y square is equal to a square, then I can write the equation of tangent as x1 plus y1 is equal to a square, and in place of x1 you need to put the value that we were using, a cos theta, and in place of y1 b sin theta, then you will be getting the slope. Okay, so I don't think that I need to do it, because it is easy and it should be left as an exercise. So from here now putting the value of cot theta, I will be getting a by b 1 by 2. Okay, so this is the slope of the tangent to circle. Now what we know, by the formula, angle of intersection will be given by tan phi, and that is equal to mod of MC minus ME, that is the slope of tangent to circle and slope of tangent to ellipse, MC into ME. Okay, so if I put the values, then it will be a upon b 1 upon 2 minus b upon a 3 upon 2. Okay, and then if you will multiply this both, okay, if you will multiply MC and ME, then what you will be getting is b upon a. Okay, you can do this in the rough work. You can, because unnecessarily the video will get longer. These are some basic simplifications that you should be able to do it. So if I simplify this further, what it will give? It will give me a plus b upon root ab. Yeah, these things you need to work. I have already done it in the rough, that's why I am writing it smoothly, and these works should be left as an exercise for the students. So from here I can write that phi is equal to tan inverse a plus b upon root under ab. So I hope that you would have liked this question. This was a question less, more of derivation kind. So I think that it would have helped you all. So please don't forget to like and subscribe the video. Thank you.